So the first project we're going to talk about is a company you might have heard of. They're called Intel. We do a little bit of work for them, not a lot. There's times that they come to us for things that their guys internally can't do. An engineer that I know that works there has a device that he uses to test the components, and he was frustrated because the test device that he had only would accept one part at a time. What he wanted to do was come up with a way to test more than one device at a time, and he realized that the chip is small, the package is small, the tray that it would fit inside of was actually pretty large, and he realized that he could fit 10 components inside this tray. This is the bottom part of the tray, and the challenge that he had was not so much the tray. That was pretty easy. The challenge was what the tray had to hold. So this tray has 10 different pockets. That's where the chips fit into, these 10 different pockets. And inside one of these pockets, this one right here, it's really hard to see because it's so small. Inside one of these pockets are a set of test pins. You can't see them because they're really, really small. Imagine, first of all, this is the size of a quarter. On this particular chip, I believe there were 292 pins. Now, he only needed to test a certain function of this particular chip, so we actually only needed 5 pins to do the testing. So here's the problem. This is the chip. This is the 5 pins on the chip. This is how big they actually are. The pin itself is 15 thousandths in diameter. The tip of the pin is 7 thousandths in diameter. So how big is 7 thousandths? A human hair is 3 thousandths to 3.5 thousandths thick in diameter. So the pin that has to fit inside these holes is twice the diameter of a human hair. So if you look at a standard high quality tape measure, the smallest increment on that tape measure is typically 1/32 of an inch, which is 0.031. So this right here is a 1/32 diameter drill. Next to it, this is a 15 thousandths 0.015 diameter drill. No big deal, right? That's what we're going to drill the large hole for the pins. And this right here is an 8 thousandths diameter drill. You can barely even see the portion of the drill that actually does the cutting right here. And the biggest difficulty of all of working with such tiny parts is getting them to drill straight without breaking, and then if they break inside the material, you've destroyed the part, and then you get to start all over again.